the other episode, the episode that I just watched, so new class of drugs now, was the Xenon episode. So you went through this experience where you were inhaling xenon gas. So what is xenon gas and what was that like?
So on the periodic table of elements, you have a column. It is the rightmost column on the table, and it's called the noble gases. And most people will be familiar with helium, which is, of course, used in balloons. It's lighter than air, so it floats. And then you have other noble gases that are lesser known, like argon, krypton, neon, radon, and xenon. I'm not reading, those are not in order for any sticklers out there. I just was randomly naming them. And the other noble gases do not have as many uses, partially because they're very unreactive. That's what the name means. They're noble in the sense that they don't react with other compounds. And that was what initially made them chemically interesting. They're also components of our atmosphere. They're in every breath that we take. Anyone that is listening to this is breathing every gas that I just named, except for radon, I hope. Maybe radon as well, but I hope for your health that radon is not one of the ones. And so they're used in neon lighting and neon signs. They're used in film projector bulbs. They're used in car headlights. They're used in ion thrusters for different types of like satellites and things like that. They have a lot of interesting niche uses, but relative to other elements, they're not used in chemistry in the same way because you can't really do that much with them. Xenon is a bit of an exception in a number of different ways. One is that it does actually form compounds like xenon hexafluoride. There's a number of xenon compounds that have been synthesized since the 60s, as well as xenon oxides. But what makes xenon really interesting pharmacologically is that it's an anesthetic at normobaric pressure. So some of these other gases, if you were to enter a hyperbaric chamber, or if you were to go, 100 feet beneath the surface of the ocean under high pressure, they would begin to induce an anesthetic effect. But that effect would be lost at sea level. Xenon is the exception. Xenon is an anesthetic at normobaric pressure, meaning that if you just fill a balloon with it and inhale that xenon, it will have a very powerful anesthetic effect that is qualitatively similar to nitrous oxide, for anyone that has tried that, aka laughing gas, widely used as a pediatric dental anesthetic. And it's a bit stronger than nitrous oxide. Nitrous oxide is not quite capable of inducing general anesthesia, especially when co-administered with oxygen, which you have to do, whereas xenon is. So it can cause a total loss of consciousness in somebody that is inhaling it. And by the standards of most anesthesiologists that I interviewed, it's basically the perfect anesthetic. Because of its lack of reactivity, it produces no metabolites. It can be recycled. It doesn't produce any known toxic interactions with the body, which nitrous oxide does, something that's a bit of a tangent, but I'm happy to go into it if you want to discuss it. And the major drawback is that this is a trace component of our atmosphere. And so in order to collect xenon for medical use, you have to distill millions or billions of liters of air to a liquid, and then you have to do cryogenic fractional distillation of that liquid air in order to isolate this trace xenon component, which can then be transferred into tanks and delivered to, anesthesiologists, or in the case of my episode.
Is that actually how they get it? They harvest it from air?
That's the only way to get it. Yeah.
Wow. So it must be incredibly expensive.
Extremely. I mean, 50 liters is maybe $1,500. So yeah, it's really, really expensive.
So what did it feel like?
It feels like, I would say, like flipping a switch of euphoria in your brain, like maximum euphoria. Like when you inhale this stuff, you enter a state of transcendent hyper euphoria that is totally obliterating, and at least for me had a kind of strong sci-fi character. Maybe it's because I'm, like I was so like consumed with these ideas about stellar nucleosynthesis and the merging neutron stars. And, of course, we know that everything around us comes from stars, but there's something about Xenon that really made me think like, wow, this is from merging neutron stars. And now
It
it's
sounds
just
like the name of an alien planet or something, Xenon.
yes. And, I believe it's Greek for strange as well.
Okay.
So yeah, there's something, and it's very, very, very dense. It's so, yeah, it is Greek for strange, and it's so dense that you can pour it like, even though it's a gas, you can pour it like a liquid into a container, and you can float a foil boat on it. And it has the opposite effect of helium, where helium, because it is lighter than air, causes your voice to become high pitched. Xenon causes your voice to become very deep and low. So it's a pretty cool element.
Is it akin to laughing gas and how it feels?
Yes.
So like
is.
a stronger, even more euphoric nitrous.
I would say, yeah. I mean, it's hard to, I'm a little bit hesitant to make a direct comparison because I've never used nitrous oxide under analogous conditions to the ones, well, I've used nitrous oxide, but not under analogous conditions to the one where I use Xenon, where I'm continuously.
You had a full mask on, you were breathing it for minutes.
Time.
Yeah.
And that immersion in the experience, I think, was really central to the profundity and strangeness. Although just even inhaling it from a balloon was also incredibly euphoric and fun.
And how do these things work? Are they NMDA receptor antagonists? What are they doing in the brain?
Yeah, they're NMDA receptor antagonists. So you have glutamate receptors in your brain, and there's a subtype of glutamate receptor called the NMDA receptor. And like I said, it's a glutamate receptor, but it has a coagonist, which is glycine. So you typically would have binding of glycine and glutamate onto the receptor, and then that causes the channel to open. In the case of Xenon, it appears to bind to the glycine site, preventing glycine binding, and that prevents channel opening, which is, in the most reductive sense, responsible for this effect.
So it's a certain very widespread receptor in the brain. Xenon is binding that receptor, preventing it from opening. What other kinds of drugs are NMDA receptor antagonists?
Ketamine, memantine, PCP, methoxetamine, 3-MeO-PCP, dextromethorphan, MK801.
So in general, it's drugs that have like an anesthetic or a dissociative effect.
Yes.